Good morning, ladies and gentlemen. Wonderful day today, Saturday, 21st January. So the second part of what causes electrical fires in hospital. We had a wonderful audience in the previous session, and we have very good responses for part 2. As you might have seen in the year 2022, we almost conducted 19 webinar only on electrical aspects, electrical safety, which is almost 2 webinar a month. We covered almost 23,000 people across the country. We strongly believe these webinars enhance the knowledge and enhance the knowledge on electrical safety. The mission is to make our nation electrically safe. So we have picked up the subject, what causes electrical fire in hospital. Many societies, many other bodies have talked about it. Safety is not something that you learn and forget it. Safety is a continuous process of learning. New gadget, new electrical equipment, new technology keep coming. How are we coping up with that? So if you have seen National Electrical Code 2023 was released on January 6th. And NFE, National Federation of Engineers for Electrical Safety, is taking up that subject of NEC, National Electrical Code of India, decoding the code. So conference will be held in the month of March 9th in New Delhi in India Habitat Center with the support of Bureau of Indian Standard. So it's the first time a society like NFE will be taking up, spreading the awareness of National Electrical Code of India. So these exercise, what we are doing as a knowledge sharing, I'm sure everyone who's participating today will take away a great learning. This webinar is an initiative by CAHO Electricals, who has been sharing various knowledges on protection, electrical safety. I personally want to thank CAHO Electric, coming forward to continue on a virtual, not only Indian participants we have people from Eastern Asia, we have from Middle East, we have people from Turkey. Many people are participating in various webinar of ours. As you all know, CAHO has introduced very important subject called Solve in 2022, a digital platform as a knowledge and process partner to ensure safe operating of low voltage electricity. And today we have a very distinguished speakers today, and I'm very proud and very happy to introduce Dr. Vijay Agarwal for giving opening remarks. He is a crusader of continual quality improvement in healthcare, as a vision to raise the bar of Indian healthcare organization to match global standards. Through CAHO, which is a national body of repute for promoting patient safety, healthcare quality protocols, and accreditation. He believes that people make quality. Driven by this passionate belief, a series of CAHO certified professional courses were established to equip and train every healthcare professional to pursue the quality journey. He was instrumental in country adopting strategy for polio eradication. He played a key role in shaping a pulse polio, the biomedical waste management scheme in New Delhi. He commenced his professional career in 1973, as over the decades earned the sterling reputation as a pediatrician and has been recognized by IMA as honorary professor. Distinguished Alumni Award for Maulana Azad Medical College, Lifetime Achievement Award by IMA and AHPI, National Statements for Quality and Excellence. We will be playing a video of CAHO once I complete introducing the rest of the other distinguished. My colleague who was on the back end, Lakshmi, will play the CAHO anthem, which was developed last year. Our next distinguished speaker, a well-known international speaker today, Mr. Gopakumar, the man tirelessly traveling across length and breadth of the country, and is also traveling overseas in addressing the issues on electrical safety. He's an engineer, electrical engineer, managing director of CAHO Electric. He's having more than 27 years of experience in electrical safety, lightning protection, EMI, EMC, etc. Carried out hundreds of site studies on failure analysis of electronic equipment and hundreds of electrical accident analysis, including various fire accidents from electricity. He conducted more than 1,000 trainings in various countries on the subject of his expertise. He is a member working groups of IEC, International Electrical Code, NEC, which is National Electrical Code of India, and BAS Technical Committee. He is also a member of National Building Code 2016. He has published articles about safety in various magazines and published the book called The Missing Link, the subject of electrical safety. Not much of introduction is required. Today is there wherever electrical safety subject comes, we could see Gopakumar there. Welcome, sir. Our next speaker, who will also be attending various question answer, is young Amaya Shaji, currently working as the manager for hospital electrical safety in Kerala region with CAHO Electric, aiming to make the hospital a complete electrical safe zone for all the patients, staffs, and other on various electrical hazards in hospitals. Biomedical engineer with 6+ experience in the healthcare industry, familiar with working environment of hospital across Kerala. Worked along with the doctor in most critical as well as sensitive part of hospital, assisting them and providing support during various medical activities. Myself, Dominic, being in the fire industry almost 35 years plus now, continue to bring awareness, continue to bring knowledge to people. The motto is to make safety as a way of life. Safety is not a choice. Safety is a necessity for your safe living and better living and happy living. That's my motto. And we will continue to bring in many more such initiatives and ensure that we as a nation become a safe country to live. That's the motto of our journey and our blue and gray. So, ladies and gentlemen, I would request my colleague Lakshmi to play the video of CAHO.
A new dawn, a new horizon of healthcare delivery and patient safety. We have a goal, a noble drive.
Hand in hand, step by step, we will drive
to march ahead together for a bright and shiny future with patient safety and quality healthcare. We are CAHO, your healthcare companion. Standing right by your side. squeeze. Walk with passion like a breeze. Training people, enhancing their skills. Spreading the message of quality healthcare for safer patient care. A better nation.
We have a goal,
We have a goal.
a noble drive.
Noble drive. Hand in hand, step by step, we will thrive. To march ahead together for a bright and shiny future. With patient safety and quality healthcare. We are CAHO, CAHO. Your healthcare companion. Standing right by your side.
Ladies and gentlemen, that's CAHO for you. We have all the eminent doctors as part of CAHO, and almost all the hospitals are part of quality improvement through CAHO. I now request Dr. Vijay Agarwal to address all the participants here, and followed by Mr. Gopakumar to do the presentation on the subject. Over to Dr. Vijay Agarwal.
Thank you. Good morning, everyone. And first of all, heartiest congratulations to the National Federation of Engineers for Electrical Safety for organizing a webinar of such an important subject. Also, congratulations are due to Mr. Dominic, who is a relentless warrior, I will say, for sensitizing people on this subject. And Dr. Gopakumar is again a very, very well-known teacher and trainer. So thanks to all of you for coordinating with CAHO to sensitize people for this very important area of safety. And as you heard in our anthem, for us, our DNA is patient safety and quality. And when we talk in today's date, so safety, when we talk about safety in hospitals, so I would say that fire safety is a hugely important thing when we come to the issues of non-medical. It's not non-clinical related safety, but fire becomes a very important part to be understood by the hospital leaders and administrators. And one of the reasons you can easily understand is that if a fire happens in a hospital, so you can imagine this, one has to imagine that there are patients who are undergoing surgery in the operation theater. There are people who are undergoing dialysis. There are ladies who are delivering in the labor room. There are newborn babies who may be in the ICU. Various kinds of patients are undergoing treatment, and they are all vulnerable. A lot of them are going to be even immunocompromised, where people not even allowed to go into their rooms. So to evacuate them will become a huge challenge, and therefore I would say that prevention of fire has to have a very high level of our focus and importance to prevent fires in the hospital. And also to understand that hospitals are, in today's date, as the healthcare is becoming very complex, the hospitals as an institutions are becoming very prone for fire, because there are a lot of heat dissipating equipments. The electrical wires are going here and there, and a lot of places the new equipments are being brought in without understanding the electrical load of all those equipments, and therefore they are very prone to fire. And if that happens, it's indeed it's a nightmare for all concerned. So I think the importance of this subject just cannot be overemphasized. And I really appreciate and congratulate the organizers for bringing about this webinar, which is going to be a continual need. We need to kind of keep on talking about it. We have to see how do we prevent fire, how do we make our hospitals less prone for fire? And in case it does happen, what are the rational actions from our side? So I'll not stand between you and the real substance that is going to come your way through Mr. Gopakumar. So over to you, Mr. Dominic. And I once again congratulate you for organizing this event. Thank you.
Mr. Dominic, you are on mute.
Oh, thank you. Thank you so much, sir. And wish you all the best for your upcoming event in April. And I'm sure directly or indirectly, we will be there supporting you on the subject of electrical safety or subject of fire. And thank you for inspirational word. Yes, such words really motivation us to continue our journey in educating people on this. Thank you very much, sir. You have a wonderful day, sir. Thank you very much. I now go to Mr. Gopakumar, the familiar face of this electrical safety and also the president-elect of NFE. Over to you, sir. I missed one slide while I was introducing, sir. I think while you before conclude the invitation, which I wanted to show, because you already shared the screen, for inviting people on 26th.
Sorry, I stopped sharing.
So an important event that's happening in the nation on 26th, on the day of Republic Day, the National Federation of Engineers for Electrical Safety will be launched on the Republic Day, which is 26th January at 4 p.m. It's a great movement, and a great institution is going to be born on the Republic Day. This is the day the journey begins to make every installation, electrical installation, safe, and bringing all the electrical engineer on a single platform. We do not have a platform for electrical engineers. We have for manufacturers, we have others, but we do not have a platform for electrical engineer to come to a single platform. I want to thank Mr. Gopakumar to take up this initiative, because he's traveled length and breadth in the last couple of years. He found that the need for National Federation of Engineers for Electrical Safety, and it will be born on the day 26 January 2023, an important day for the nation, for the initiative of our Honorable Prime Minister, Mr. Modi ji, and also for Bureau of Indian Standard for supporting the cause of National Electrical Code to spread across the corners of this country. So I would request all the participants who are here and who's continually participating to please attend and understand what is National Federation of Engineers for Electrical Safety. So my colleague Lakshmi will be sharing the link on the chat box. You can use the chat box to join in and register. I'm once again thankful for creating this body. I want to thank Mr. Gopakumar and his team to design this platform for all the safety engineers, electrical safety engineers. Over to you, sir. Thank you so much. God bless you.
Thank you, Mr. Dominic. Thank you very much for the introduction and the introduction of our launching of the program. Thank you very much, Vijay Agarwal sir, for giving a motivational speech. So let us start the main technical part. Without much introduction, I would like to go ahead. I hope my screen is visible and the sound is also clear. So, in the first session of our program, we discussed about the problems in the medical area, especially the patient environment and the fire or shock and the related problems. So today we will go one step ahead and especially find out one or two of the issues which is faced by the industry, especially in fire. First, we should understand that electrical installation in hospital is a special thing. There are normal location and medical location. Medical location means a location in a hospital which is classified as Group 0, Group 1, and Group 2, especially Group 1 and Group 2 medical location, where biomedical equipment are constantly in touch with the patient, and most often the biomedical equipment are bypassing the skin. If we look at the statistics, almost 33 fire accidents happened, major reported hospital fires happened from 2010 to 2019, and about another 24 accidents happened, major ones happened during the COVID time, and approximately 78% of fire due to electrical problems are mainly from places where air conditioner fire is one of the major threat, especially if you have this window or the split air conditioners, and more than 100 or 124 people passed away during this time, especially in hospitals alone. So we actually made a kind of a survey to find out how system can be improved. Then, based on the survey, we categorized the hospitals into three categories. Small hospitals, where we have considered only the inpatient hospitals with inpatient facility. There are small hospitals up to 50 kilowatts of load. There can be one low voltage supply from the utility company, and major loads are air conditioners, fan, small biomedical equipment. And the next level is probably the medium-sized hospitals, where the connected load is 50 to something about 300 kilowatt, 300, 400 kilowatt. Here the problem is, instead of going for a high voltage supply, most often each building or each part of the building or some part of the building, there are multiple LT supplies from utility, multiple low voltage, low tension supplies are taken. Then once when multiple supplies are taken, sometime the wiring practices are not followed properly. These hospitals, the kind of load, majority is air conditioners, then X-ray machine, CT scan, light fittings and fan, small biomedical equipment, and so on. Then we have the large category of hospitals where HT supply, high voltage supply is available, proper transformers and all. We tried to make a survey, and the report of the survey, for example, in small hospitals, general subject, for example, whether they have a responsible person, or whether people know where the electrical switchboard or where the MCB distribution board are there. If we ask the hospital people, yes, they know where the switches sockets are there, but most of them doesn't know where the MCB DB is placed. That means in case of any disconnection, then it's a little bit trouble. Technicians, most often there is no tools available, and most often they don't know the circuits from where the DB, through which direction the routing of the cable is carried out. There is a socket. If we ask which MCB is connected to this DB, then probably most of the time, 70% of the cases, this information is missing. Most often, small hospitals, in case of any doubt, they call their contractor, who is probably who did the job a few years back, to understand or to know further. With respect to safety, in smaller hospitals, smaller to medium, most of the safety requirements are unknown. It's very rarely known. The installation looks like a TT, but most often the system earthing, which is the most important for electrical safety, it looks like TT, but it's a very, very inefficient way of, let's say, TNS or TNCS. And subjects like fault loop impedance are rarely known. RCDs and the earth fault protection in hospitals which is more than 10 years old, most of the hospitals RCDs are, there are no RCD. And hospitals which is less than 10 years old, of course, in some of the cases, RCDs are used. Probably 10%, 20% of the circuits have RCDs. Safety services, installed safety services means for the firefighting or emergency, the systems are installed, but it is not maintained well. Most often it's not in working condition. Fire survival installation is very rare. This is the first part, the safety subjects which I have shown is for the general electrical installation, whereas for the medical location, let's say group 1, group 2 medical location or group 2 medical location where continuity of supply is necessary. In most cases, this subject is mostly unknown, unfortunately. Class 2 medical location shock reduction measures or group 2 medical location, the shock reduction measures are very, very rarely known. One of the subject here is supplementary equipotential bonding. I explain it later. And the subject like EMI, EMC is very much unknown. In most of the hospitals, not most, almost 100% of the hospitals, the management is very much interested to improve the system. But most often, the guidance provided by the expert is not correct. I would say most often they are misguided. In large hospitals, the information about general, for example, there are responsible people available, technicians available, sometimes engineers are available. But again, very rarely electrical engineers are there, but most often there is somebody who can take care, and they are trained people. Approximately 50% are known and they know what to do, and they are trained. Again, in most of the cases, in case of doubt, they have the habit of calling the electrical contractor to find out what exactly has happened or what exactly has done. In these cases, overload protective devices are installed. Protective devices such as from the starting, for example, air circuit breaker, molded case, MCCB, MCB, fuses, all those things are installed. So chance of fire due to overload is mostly less in this particular case because proper devices are there. Unfortunately, the devices are not tested. So we really don't know whether these devices will trip or not. You must have seen the first days our video where there was a fire in an appliance. The fire has become a major fire. The ignition has become a major fire because the protective device didn't trip. We generally call fire due to overload or short circuit. Actually, the problem is the fire is because of non-disconnection or delayed disconnection of the protective device. With respect to information on safety in large hospitals, the system earthing like TNS, TTIT, system earth is very rarely known, and most often it is misinterpreted. Again, the system looks like a TT, but here in a larger hospital, this situation is even serious than a small or a medium hospital. In a small medium hospital, of course, the supply is LT, whereas in a larger hospital, the system looks like TT because, but unfortunately, very, very inefficient TNS or a TNCS kind of thing. Fault loop impedance and disconnection, unknown more than 90% cases. RCDs and earth fault protection, very rarely used in modern hospitals. Yes, of course, nowadays the number of usages are increasing. Safety services are installed and they are maintained well, almost in 50% cases. Then fire survival installation for safety. So most often, the fire survival people think that fire safety is about using a wire which can withstand a fire. It is not like that. Fire survival installation means the whole electrical installation shall withstand for certain time. It is not only the wire. So you should also think you have to change a little bit. It is not only about wire, the whole electrical installation should they have to survive fire. Safety in medical location, continuity of IT supply, mostly it's unknown, 80%, and about 20% it is known. Class 2 medical location shock reduction measures are again unknown. 90% cases, the shock reduction supplementary protective equipotential bonding is missing. In some hospitals, of course, there is a rubber flooring made, thinking that this may protect from shock, but that most often in a conductive location where conductive fluids are sometime on the floor, it will be very difficult to achieve safety in that way. Of course, that the rubber or the plastic flooring is required, but protective equipotential bonding is also required. You cannot avoid it. Then EMI EMC is most often is unknown, but almost all of them are aware of the shielding in the radiation application in certain areas. They know that EMC protections are necessary, because without that the equipment will be quite dangerous. The managements are very much interested in safety measures. Again, I would say misguided. One of the misguiding, I always make a comment about this. People think that by making thermography, the complete electrical safety is made or possible. Actually, this is wrong. Thermography, it can, of course, tell you the hot spots. It can increase the safety, but it doesn't mean that complete safety is achieved by doing only thermography. You have to make all the recommended safety measures as per IS 732. There are 18 inspection points and 10 testing points plus medical location additional testing. Over and above, you can do thermography. If you do only thermography, please don't think that we will achieve safety. Here, the problem of thermography, the live conductors are, the loose contacts in the live conductors are known, whereas the earth conductor or protective conductor, you cannot find out the loose contacts and problems in the protective conductor. So the IS 732, also the National Electrical Code 2023, which is launched 6th of January, has recommended two testings which can find out loose contacts in a wiring. Test number 1. This is called as continuity resistance of the wiring. You are supposed to measure the continuity resistances. And test number 2 is fault loop impedance. With these two tests, loose contacts not only in the phase or neutral conductor, but on the earth conductor also can be found out. So another misguided system is sometime, I would say, fire survival cable can reduce fire. Because, for example, in one of the report, I have seen that there was an air conditioner fire, and the report says all wires should be fire survivable. Actually, this is again not the correct information. The fire has started from the air conditioner. Even if you use a fire survival wire, the problem is in the air conditioner, not in the wire. So the recommendations in the standard, if we look, you should use class 2 copper conductor. Fire resistant installation for safety services are mandatory. The wiring system shall be mounted and installed in such a way that circuit integrity will not impaired during fire, and so on. Another issue is EMI. I would say harmonics is one of the subject in EMI, especially in hospital. There are several issues: harmonics and interharmonics, signals superimposed on power lines, voltage fluctuation, voltage dips, voltage unbalances, power frequency variations, induced voltages, and so on. There are several issues because in a hospital, a lot of equipment are used. This particular video, you can see. So this is, in this particular case, you can see on the screen the white grains. These white grains are actually because of an EMI issue. And this EMI, most often it is from, for example, an LED light which is close by. Or maybe from an air conditioner nearby, inverter air conditioner, or maybe from an UPS nearby or on the next room. So what happens is, because of this kind of misreadings, I put the video again. You can see the grains here, the white grains. Because of this misreading, imagine a patient is connected with biomedical equipment, and the equipment are showing some wrong readings. It can lead to a serious incident. So this is actually very, very important. EMI is a very important subject in hospital. The second issue which we face is fire from air conditioner. You can find out a lot of news from the our newspaper and media about the fire in hospitals. One classic example here, there is a fire from the air conditioner indoor unit. Now, for your information, the government of India has made ISI marking mandatory for air conditioners from 1st of January 2023. So, ISI marked air conditioners are only can be sold in the market from 1st of January 2023. And here there is a small issue in the sense the test standards which the air conditioner compliance required is IS 1319 2017 and the IS 1319 part 1 and 2 for unitary air conditioners and split air conditioners. So in the market, whatever you are buying nowadays, you have to check whether the air conditioner is ISI marked. But I would recommend not only that, there are some additional standards with respect to safety. For example, IS 302 part 1, this is talking about safety of household and similar electrical appliances. This is 302 is actually a mandatory requirement for all electrical appliance which is used, and this 302 again it is from IEC 60335 part 240. There is an IS code or IS standard 2018. This standard is specifically requiring additional safety measures for air conditioners. The issue is mandatory marking. The recommended standard is only 1319, but in the letter, mandatory marking for 302 and 60335 240 is not mentioned. As a result, there is a chance that manufacturer may not test as per the 302 or 60335 240. So once when you buy an air conditioner, you must check whether it is ISI marked. Plus, you also please check whether the air conditioner is tested for all the safety parameters as per IS 302 and 60335. For example, I just made a comparison. We made a detailed study and one report we are trying to publish. For example, point number 3, high voltage test, electric strength test, which is very, very important for an electrical appliance because most often failures are due to insulation failure. The IS 1319 is asking for 1,000-volt test for 2 seconds. That means between the phase or the neutral conductor and the body, 1,000-volt is applied for 2 seconds and the equipment shall not fail. But in reality, the duration which is shown 2 seconds is quite less. In practical, they are supposed to make the test for 1 minute. The IS 302 recommend to make this test for 1 minute. So the ISI marked air conditioner, you can be sure that 1,000-volt 2-second test is made, but you should also check IS 302 whether the air conditioner is tested so that a higher, the test is made with respect to continuous voltage 1 minute. Say, for example, transient over voltage. Every electrical appliance which is used in an electricity, we are supposed to, or the equipment manufacturer is supposed to categorize the equipment as per over voltage category. Air conditioners are actually part of fixed electrical installation. They are not portable appliance. They are fixed electrical installation. Generally, they have to come under over voltage category 3. That means the air conditioner must be tested with an impulse voltage of 4 kV. So an air conditioner tested as per IS 302 coming under impulse voltage category 3 is the best solution. Similarly, for example, the IS 1319 is not talking about glow wire test, whereas IS 302 talks about glow wire test. So you must be careful while buying new air conditioners. Please be careful. 70% of the fire in hospitals are from air conditioners, especially these window or split air conditioners. So ensure that the new air conditioners which you are buying is having ISI mark and in additional tested as per IS 302. All the electrical parameters are tested. And when you install it, be very careful about voltage stabilizer. If you use a voltage stabilizer, instantaneous tripping of MCBs may not happen. During a short circuit, the MCBs may not trip instantaneously. Of course, overload protection is possible, but the instantaneous tripping may not be possible because voltage stabilizers are adding impedance in the circuit. As a result, fault of negligible impedance or short circuit current is reduced and the disconnection time will be higher, resulting in a fire. You have to be very careful. Now, from the survey, the general findings which we see is a lot of cases there is no protective conductor, there is no earth wire in the final circuit. In the final circuit, in the sense, in the medical location, there are the sockets available. There is no earth wire on the socket. Most often these are disconnected, damaged protective conductor. Number 3 is undersized protective conductor. That means the phase and neutral is 16 square mm, but the earth wire is only 2.5 square mm. This is actually a violation. Up to 16 square millimeters. Phase, neutral, and earth must be same size. The RCDs are not there. Large hospital with own transformer has non-standard system earthing. TT is widely used instead of TNS as recommended on regulation standards and so on. Continuity test to find out loose contacts not carried out, unfortunately 100%. Fault loop impedance not carried out 100%. Methods to reduce insulation degradation not carried out. Too much earth pit, violation of safety requirement. Isolators are used instead of MCBs. Origin of a circuit is not traceable. These are some of the issues which we see, which we find. Now, please note that in a properly designed, erected, and tested electrical installation, overload and short circuit shall not create any incident because these protective devices are supposed to disconnect, provided they are not only selected properly, installed properly, but they are also tested properly. Most often, this testing, especially fault testing, the disconnection of the protective device during an earth fault is very, very rarely happening because we use a kind of a TT system. TT system in the sense the transformer neutral is connected to earth pit and the panel board earth bus bar is connected to a separate earth pit. As a result, it becomes a TT system, but sometimes underground these are also connected. Then it becomes an inefficient TNCS system, which is very dangerous. Disconnection recommended within the recommended time of 200 milliseconds may not happen. You must understand that wiring and the equipment can withstand fire or withstand a higher current only for a short time. So basically, the disconnection may not happen. Now, with respect to fire, there are a few concepts which is included in the design standards. One of the concept which is included is, for example, in the table, in the figure which you are seeing, the green color, power in watts. It is nothing but the power dissipated due to a fault. Whatever the maximum size of the power, let us say, for example, 4,000 watts or 2,000 watts, if the fault is cleared within 3 seconds, so here 1, 2, 3, 3 seconds. If the fault is cleared within 3 seconds, the chance of ignition of fire is quite less. Or if the heat dissipated is less than 15 watts, even for a longer duration, then the chance of heat or chance of ignition of fire from electricity is quite less. But limiting the heat dissipated to less than 15 watts is quite difficult. We have to have a power supply with a limited current, which is another technique. But The simplest technique which we can implement is ensure that the device is able to disconnect within certain time, within the recommended time. Similarly, the second concept is a heat dissipation due to a fault. If it is limited within 5 seconds, then the chance of ignition is possible only under some conditions. Similarly, if the heat dissipation is limited to less than 100 watts, ignition is possible only under some condition. If exceeding these limits, of course, electricity is dangerous. It creates fire, and the electrical power source is classified with this particular idea: power source 1, 2, 3, and electrical wiring designs or electrical wiring recommendations in the standard are made based on these power source classification as well. When we select an MCB for a typical application, please be sure that it is not just like for a typical application, think that today I need 10 amps current and tomorrow I may increase it to 60. So now itself, let me use 63 amps MCB. This is a wrong idea. So the correct way of using protective devices, first of all, the protective device is to protect the circuit. So in order to protect the circuit, the first item which is on the circuit is the wire. So the device should be selected based on the wire size. And here you must understand that every protective device have got a conventional disconnection time and conventional disconnection current. Conventional disconnection time is 1 hour, up to 1 hour. Conventional disconnection current is 1.45 times. Similarly, positioning of the device, very important. For example, I just put the tripping curves of MCB, B, C, D MCB. All the three types, B, C, or D, up to 1.13 times the nominal discharge current, the device is not supposed to trip, no tripping. Similarly, 1.45 times into IN, the disconnection time, this is called as conventional disconnection current. Conventional disconnection time is up to 1 hour for devices less than or equal to 63 amps, 2 hours for devices more than 63 amperes. It means your wire should be able to withstand a current of more than 1.45 times the rated current of the protective device for at least 1 hour or 2 hours in case of device more than 63 amps. Similarly, 2.55 times the rated current, the devices will trip within 1 second, and the instantaneous tripping is happening 5 times IN, 10 times IN, 20 times IN for BCD type MCBs, as shown the disconnection time. So if you use stabilizer, the problem is here the instantaneous tripping, or sometime 2.55 times the nominal current. These calculations are missing. As a result, the MCBs may take much more time to trip, ending up with a fire or an accident. With recommend to the requirements of the standards and codes, all of you know very well that we have the National Electrical Code of India 2023. With respect to hospital, the NEC has got 8 parts. Part 1 consists of 22 sections. All these 22 sections are mandatory. Part 2 talks about supply system like DGs and transformers. Then part 3 talks about special electrical installations such as bathrooms and wet areas. And for example, part 3, section 9 talks about medical location, group 1 and group 2 medical location. Please download the standard which is available at free of cost. You have to go to the BIS sales portal and you can download the standard at free of cost. It's a 800 plus page document. Now we are starting mass awareness campaign for the National Electrical Code. Probably we will be able to support you in understanding the standard. The standard NEC recommends 19 inspection points in section 1, part 1, section 17. And there are 10 testings included in the NEC. These 10 tests we have explained last time. Also, we are explaining in several programs. It starts with continuity of conductors, then insulation resistance of low voltage and extra low voltage, insulation resistance or impedance of floors and walls is one of the test. It is just to find out whether the floor or the wall is in a dangerous situation to create a shock. Then the test number 6, automatic disconnection of supply. Please note that out of these 10 tests, 4 tests you doesn't require power supply. Power supply should be in off condition. And 6 test power supply should be in on condition. On condition in the sense you need the actual power supply. Here, sometimes we face a challenge. Once when we go for the client, before commissioning the transformer, they say, you come and do a test because now we have a temporary power supply, and with the temporary power supply, we are forced to do the test. Actually, this is not correct. If we do the test with a temporary power supply, with the actual power supply or actual transformer, we really don't know what is going to happen. So we need to do the test, these 6 tests with the actual power supply, actual transformer, actual DG. Medical locations are very special. In the last presentation, part 1 of our program, we explained, Amaya explained it very clearly and in a very understanding way. So these locations, there are several special requirements. We also explained about micro shock, macro shock, and the problems with respect to micro and macro shock. Also, the additional safety measures required in a hospital in comparison to a normal electrical installation. These are actually the points which I am going to explain. These are actually included in the National Electrical Code as well as the regulations. So these becomes mandatory. Power distribution and safety. First of all, the system earthing must be at TNS for general areas, and automatic disconnection in general areas is a safety measure. Continuity of supply in group 2 locations as per IS 17512. Of course, these the NEC National Electrical Code also explains both these requirements. Patient environment, then in general care areas, 500 millivolt under normal condition. The potential difference between 2 simultaneously accessible metallic parts must be lesser than 500 millivolt in general care areas, and in critical care areas, the voltage between 2 simultaneously accessible parts should be lesser than 40 millivolt under normal condition. This 540 is under normal condition. So the supplementary equipotential bonding must be very, very efficient to reduce the potential difference lesser than these. You see, 40 millivolt is a negligible voltage, but this more than 40 millivolt itself sometimes is deadly for a patient. And during fault condition, the potential difference must be limited to less than 25 volt. So very important supplementary protective equipotential bonding. The next part is current loop. Potential differences and unintentional current flow through patient. So this is actually a serious issue in a hospital. Here, what you should do is all intensive care units must have single earth for each patient, isolated from safety earth. So this is actually a system which is recommended for hospital. It doesn't mean that you need to have separate earth pit. The recommendation here is each single patient or an area where you have an ICU, each patient area should have only one earth. That means a very good equipotential bonding must be made, and this can be isolated from safety earth. This is a kind of a functional earth. We will discuss it maybe in another program, because this is itself is a much bigger subject. Maximum 40 millivolt potential difference in any conductive surfaces must be made. So then you can also go for safety measures such as electrical isolation with an isolation transformer, barriers, then increased safety measures are also required. Similarly, the NEC is recommending additional testing for hospital medical environment, there are 5 tests. The first one is insulation monitoring device should be tested. The second and third are both related to shock reduction, supplementary equipotential bonding, and facilities for equipotential bonding, the efficiency of these bondings. Please note that bonding means you take a wire and connect it to metal parts. Then you check and find out the actual potential difference between these two parts, and it should be lesser than 40 millivolt, for example. Then safety services, and the standard also recommended here the frequency of these checkings as per the standard. Similarly, the NEC had given one more information. Sorry, there is a spelling mistake. It is NEC of India, not NEF of India. The buildings are classified based on the National Building Code, Group A, Group B, Group C, Group D, Group E installations. Now, Group C, the medical and hospital and sanatoria comes under Group C, especially C1. Here, the recommended periodic verification for the general area is 2 years. So, please make a note of it. Now, with respect to the concept, most of you know very well, because I am showing or explaining about this safety measure in almost every electrical safety class. The concept of safety, there are 2 concepts. The first one is called as the earthed power supply, which is for general locations where protective equipotential bonding and disconnection of the supply is mandatory. Whereas the concept number 2 is for medical location or for safety services, where unearthed supply can be used. In an unearthed supply, the power supply continuity is ensured even during the first fault. So we have to, or the person who is using, or the person who is designing or making a safety audit, he must understand the difference between these 2 systems, and he should make it. When it comes to earthing, one more point you should understand is electrical appliances are of 3 types. In fact, there are 4 types. Class 0 is also there, but nowadays class 0 is banned. So basically, electrical appliances are classified into class 1, class 2, and class 3 appliance. Class 1 device require protective earthing. Class 2 devices are basically device with 2-pin plug. Protective earthing is not necessary, but sometimes functional earthing is required. Here on the right side, the symbol shows functional earthing. Class 3 devices are operating with a very low voltage, sometimes a voltage which cannot create a shock hazard. In this case, also protective earthing is not required, but functional earthing may be required. So whenever you make a protective equipotential bonding, first you should also consider the type of equipment which you are going to use. And the functional earthing, the recommended color is cream. So understanding the earthing requirement in a medical area, it is a little bit critical. It is a little bit technical as well. But you know what I am showing in the picture, 5017, 1819, and 20. These are called as the earthing symbols, which is mentioned in the appliance. The appliance manufacturer should take care of his requirement, and the appropriate marking must be made. The installer or the designer of that particular location, he has to understand the meaning and the method of making the earthing, and he should make. As I said, in the National Electrical Code, you can see this particular picture. This particular picture is explaining about protective equipotential bonding. Protective equipotential bonding means all dead metal parts in your building, such as M stands for exposed conductive part, CP, these are some kind of metal installations, extraneous conductive parts. If you go for a TT system, then one building require one earth connection to earth pit. MET must be connected to earth pit at least once. Then if you go for a TN system, the MET has to be connected to the transformer neutral, and this is called as protective equipotential bonding. What is required extra in a medical location is number 4, which is called as supplementary equipotential bonding. So this picture is also included in the NEC, and near to that, a lot of explanations are given. Please go through it and make it. So earthing is called as protective earthing, protective equipotential bonding, which consists of main and supplementary equipotential bonding, and automatic disconnection of supply within the specified time. If this safety measure is properly implemented in a hospital, the chance of fire from whatever reasons, especially air conditioner or fire from the medical locations, it can be almost nullified. This picture from IS 3043, again, just to show that earthing doesn't mean neutral two separate pit, bodies two separate pit for DG and transformer. It is absolutely wrong. What you should do is a protective equipotential bonding. Neutral of the transformer or DG has to be connected to an earthing bar. I am talking, this picture is basically for place where you have your own DG, body, alternator, and neutral connected to the common bus bar. And this is the correct way. Now here in IS 3043, you can see this particular symbol, which is called as 5020. It is not exactly to an earth pit. It is the chassis earth. Chassis earth means the frame or the chassis where you are going to. It is the chassis earth is also nowadays called as functional bonding. Functional bonding. Similarly, the MET has to be connected to extraneous conductive parts, and this is the correct way of earthing. You can also find the additional pictures in both IS 3043 and IS 732, and the explanations are also provided. Another important subject is fault loop impedance. Engineers, those who are practicing in the hospitals, please note that the equipotential bonding and fault loop impedance both are highly important. Both are included with very good explanations in the National Electrical Code. You can also find the tables, fault loop impedance recommended for each type of MCB. So the simple method which you should understand is resistance of the wire influence the disconnection time. Testing of fault loop impedance is highly important. Now I am moving the cursor in the location, live metallic body. It is connected to the neutral of the transformer through a metallic connection, metallic conductor. So the exposed conductive part or the extraneous conductive parts are finally connected to the neutral of the transformer through a metallic connection, and this metallic protective conductor must run along with the phase and the neutral conductor. Don't try to route it through a different route. So there are some rules which has to be followed here. Please don't believe subjects such as chemical earth, analog earth, digital earth. There are a lot of claims happening in the market. People claim that I have a digital earth which will solve all your electricity related problems. Don't make earth farm all around your hospital because this is also not correct. These things will create more problem. Average, if we look all around a hospital, a lot of hospitals have got the earth farm 50 to 100 numbers, which is not correct. The correct way of earthing, I just skip these slides. I actually don't want to show that, but unfortunately I forget to hide it. So the correct way of earthing is protective equipotential bonding. So lightning protection, functional earthing, protective earthing, everything must be interconnected. Now, one important subject which I would like to explain, because during the last program, a lot of people asked about lightning protection. Somebody said there is some court order or there is some ruling and so on. I would like to explain that particular subject here. In India, there is a nice story about lightning protection goes on. Manufacturers claim that I have an advanced lightning protection rod, which is very special, and it can protect up to 100 meters or sometime even much more than 100 meter. There were some videos where people are climbing up to 2 kilometers. One rod protecting 2 kilometers of radius is really a nice idea, but not practical. So basically, these non-standard system claim that it protect up to 100-meter radius, and you need to have one down conductor, 70 square millimeters of copper wire, and one earth pit. So basically, one rod, one down conductor, and one earth pit. And this down conductor can be routed through anywhere, most often through electrical shaft. And then the owner of the building believe that he is protecting not only his building, but he is also protecting all his neighbors. This is absolutely the only word to be called is it's a non-standard system. National Building Code 2016 recommended not to use this system. It cannot provide any safety, and routing down conductors through shaft is a serious violation of safety. Now, these manufacturers, as an argument, these suppliers, they claim that this is as per the French code. It is as per the French standard. Then users sometimes believe that French standard is also a good standard. Let us follow. But please note that the French standard is asking not for one down conductor, one earth electrode. The French standard is explaining the system in detail. You need to have several safety measures in a building. Over and above, you see this item number 1. This is the ESE rod. So basically, you need to have serial number 1 to 18. If you go as per the Indian standard ISIC 62305, you can achieve safety by using items serial number 2 to 18. Item number 1 is absolutely not required. Whereas the French code is asking to put an additional rod. Please note, additional rod. Whereas the same system, manufacturers take it to India and they say that one rod protect 100 meters. You take one wire and connect to the earth pit, your lightning current will go, like water through a pipe, which is absolutely wrong. So one rod, one down conductor, and one earth pit is a marketing tool. And this marketing tool is actually fooling engineers. All engineers are made fools, because if we know how a high frequency current works, then you will not accept this one down conductor principle. Also, there was a big fight went on in the market regarding this non-standard lightning protection. In a meeting in BIS, there was a delegation from France and from Australia came. There was a meeting held. Those documents are available in the public domain. So one French manufacturer agreed that ESCs are not installed as per the national French code. So they told that, yes, there is a French code and you are supposed to use it as per the French code. But in India, nobody uses ESC as per the French code. And they also blamed that the consultants don't know about the French code. As a result, the consultants are responsible for the one rod, one down conductor, one earth electrode. Consultants or the safety auditors are responsible, and the manufacturer is not responsible. Basically, they made the story of one rod, one down conductor, and one earthing, sold it, and finally they say, I'm not responsible. If you still wanted to use these non-standard items, please download the National French Code 17102, then do as per this particular code. Don't believe the manufacturer's claim of one rod, one down conductor, and one earth pit, because it is just to fool engineers and to make business. Lightning protection must be carried out as per IS IEC 62305. Especially in hospitals, you must follow this particular standard, because the electromagnetics of the lightning can damage your electronic equipment. Now, a properly or a well designed and installed lightning protection only can protect your electronic appliance. So with this, I would like to stop today's presentation. And as I said, 99% of the electrical accidents are we are able to solve. We can avoid, or these accidents are avoidable. Please note that the installation must be designed, erected, and tested as per the National Electrical Code of India 2023. So if the building is made as per this particular code, you can be sure that 99% fire accidents can be avoided. Then number two, as Mr. Dominic told, 26th of this month, the coming week, we are going to launch, or we are going to start the activities of National Federation of Engineers for Electrical Safety. Now, with the NFE, we are trying to make a large scale classes on NEC. Classes in the sense, 1 hour or 2 hour class may not be sufficient to learn the whole subject. It may be sometime 30 to 40 hours of training. So we are going to start long-term trainings. We request you to participate in the programs so that you also will be able to learn a lot. So by this, I would like to thank all the participants. We go for the question answers. Over to you, Ms. Lakshmi. I think probably you are on mute.
Yes, sir. So the question is from Mr. Arvind Gupta. What is the life of overload safety devices?
Okay, I could see the question. Probably I will help you in also reading the question.
Yes.
Life of overload safety devices. Normally, the life of an electrical installation, if the temperature rise is limited to less than, for example, in a wire 70 degrees, then PVC insulated wire is about 20 years. But safety device, normally 20 is the minimum, and an average probably 30. If it is maintained very well, it can even go to probably 40 years. More than or up to 40 years is easily possible. For example, the verification in the sense, the testing of the installation, what is recommended in Europe, say for example, Belgium, in residential application, they are asking for a re-verification or retesting once in 25 years. So once in 25 years, it's an indication that if you make an initial verification perfect, then the life of the installation is at least 25 years. So on an average, let's say 25 to 30 years is the life. The second question, what should be used for an AC if voltage stabilizer doesn't help to reduce fire hazard? You see, nowadays, earlier days, the voltage fluctuations were quite high. But nowadays, with the arrival of modern air conditioners or inverter air conditioners, they are actually able to handle a wide range of voltage. So nowadays, actually, you don't need a voltage stabilizer, but the shopkeeper often sell because it's an additional item for them. I would recommend. I also saw that some of the air conditioner manufacturers are nowadays recommending not to use a stabilizer. So you can connect it directly to the AC line. So you don't need to use it. Is there any guideline? A question from Mr. Arvind Gupta. Is there any guidance of IS code for replacement of old safety device? Actually, there is no guidance in that way, but there is a guidance of retesting, because once when you test it frequently, then you will understand whether the system is in working condition or not. Based on that, you have to replace. If the systems are in working condition, probably you don't need to replace. So, somebody, Mr. Harsh Sharma, is asking for a certificate. Actually, Mr. Sharma, this certificate, participating in an hour presentation may not help you in improving the knowledge. This can only taken as an informative session. You got some information. So getting the certificate may not be of importance. You have to then participate in a long-term technical class. So there is a question from Mr. Abdul Azim from Hyderabad. Okay, he is asking for the presentation slides. Mr. Azim, we will be uploading the videos of the presentation in the website. Once when it is uploaded, you will get a email. Please look at the video. Presentation slides we cannot circulate because we are preparing each program, 1 hour program. Behind this program, we are spending at least a day for preparation. So you have to look at the video. The earth conductor of TNS should be insulated. Question from Mr. Amritlal. No, it can be the functional earthing must be insulated. So your question, earth conductor. Please note that earth conductor or earthing conductor means the conductor from the earth bus bar to the earth electrode or some kind of buried metal part. That conductor must not be insulated. Otherwise, a protective conductor can be insulated. It depends on the situation. Functional earthing must be insulated. So earthing conductor need not be insulated. It has to be a bare conductor. The frequency of electrical audit, Mr. Mahesh is asking, Mr. Pandurang, Mahesh Pandurang, you have to refer to the part 1, section 17 of IS, the National Electrical Code. There is a table provided. I think it is annexer D or E. Please look at the annexer D or E. Depending upon the type of the building, the electrical, the verification, re-verification frequency is recommended. Mr. Iman Maulavi, ESE vendors are now using Karnataka High Court judgment saying NBC has accepted their claim. Can you please explain what was the result of the judgment? Oh, this is actually wrong. NBC, you see, not only in India, worldwide, standards are a recommendation. Standards are not a mandatory rule. A standard is made as a mandatory rule by the appropriate authority. That means there are 2 ways. One is the appropriate authority. For example, the municipality or the state government or government of India. If they say that every building in India must be as per National Building Code, then it becomes a mandatory rule. This is provision number 1. Part number 2 is, if NBC is referred in any agreement, let's say, for example, you are constructing a building, and in the building agreement, somewhere you have mentioned the design, the architect, while designing the while publishing the tender, he must have written, the concrete has to be as per NBC, the structure has to be as per NBC, and this has to be as per NBC, that has to be as per NBC. If NBC is referred in these agreements, then it is like a rule. It is mandatory. So if your document doesn't contain anything about NBC, if you are not at all referring your building to NBC, then it is actually not a mandatory. But if you are referring somewhere in your document as NBC has to be followed, then all the rules are mandatory. So basically, Bureau of Indian Standards gave a reply to the notice saying that NBC is not the authority. It is a voluntary document, so it has to be decided by the authority or the people, those who are making the agreements. So that is the correct way. So the court has rejected the complaint. The court has dismissed the petition. Petition was filed by the ESE vendor. So they are actually, it is dismissed. Their claims are not even accepted by the court. So that is what has happened. It is not that BIS accepted that NBC is voluntary. By rule, all standards and code of practices are voluntary. It becomes a mandatory once when you include it in any rule or once when you include it in any agreement. So the next question from Mr. Sitarama, will there be any problem of multiple LT power supply used in small and medium? Yes, multiple LT supplies sometimes is a problem, because if you are completely isolating one building or one portion of the installation, only one supply, then it is often good. But most often what happens is, after a few years of operation, one room itself will have sometimes 2 supplies, which is really dangerous. So please don't do it. It can be hazardous. The next question from Mr. Rishabh Rathore. The fire started from AC in Vijay Vallabha Hospital in Virar outside Bombay, which killed 15, and the Ayush Hospital in Surat, which killed 3. The air conditioner has been for 24 hours in both incidents. So thanks for the information, Mr. Rishabh. Yes, of course, not only these 2 accidents, a lot of accidents are happening due to air conditioner. But the next time once when you buy an air conditioner, please ensure that it is ISI marked and additionally tested for the IS 302. Then you get a good quality. Of course, it will be a little bit expensive in comparison. So there is a question from Mr. Prasad Rao Swami. Fire survival cable misconsumption is because of manufacturer's advertisement. Some regulator can impose sensor certificate for advertisement. Unfortunately, this is not possible because in all our advertisements, this is how the market works. I have no comment on that question. So I skip a few of the questions which is not related to our subject. Today, Mr. Dominic is not present in India, so he is a little bit out. That is why I am handling both the things. Mr. Ramakant Sharma, for large hospital where what are arc flash protection device and the insulation resistance protection? Mr. Ramakant, the arc flash protection, as I said, these what is recommended in the books are the 18 inspection and 10 testings. And over and above, you can go for arc flash. Of course, we will try to make a webinar on arc flash probably in the next occasion. Mr. Riaz Ahmad, could you please put some light on Federation of Engineers for Electrical Safety? Of course, Mr. Riaz, we will do it on 26th of this month. That is on Thursday evening 4 o'clock. Please join us. We will explain you what exactly we are looking for. Mr. Subhash Mishra is asking what is the average life of chemical earthing. Mr. Subhash, the chemical earthing itself is wrong. So we don't need to talk about its life. Is NEC mandatory in case of violation? What will be the action taken by and by whom? Question by Mr. Imran Maulavi. Mr. Imran, you must understand that the regulation, that means the safety regulations of Government of India, which is called as the CEA, Central Electricity Authority, measures relating to safety and electric supply. An amendment is going on. The new regulation, regulation 14, sub-regulation 2, what it says is, any subjects which is not included in the regulation, you must refer to National Electrical Code of India. Or it shall be, National Electrical Code of India shall be followed for anything which is not included in the regulation. Now, the regulation talks mainly about generation, distribution, and generation, transmission, and distribution. Of course, something is also included as in an installation. For example, the new regulation 38 includes safety requirements in a high-rise building. So there it's very clearly written that every building more than 15 meters height must be designed, erected, and tested as per National Building Code of India. That means it becomes a mandatory requirement. It also has written hospitals and medical locations must follow NEC irrespective of height. So this becomes again hospitals, you must follow NEC. So with the regulation, the NEC has become mandatory. Now, who is responsible for taking the case in case of an who will take the action? Of course, this is by the electrical inspectorate or the respective government authority, maybe police or whatever. Then the punishment. There is a new Electricity Act coming up, not the new, but some amendment is going on where the violation will be penalized for up to 1 crore rupees and I think some imprisonment. So the things are changing. Users should be a little bit careful now. So to simplify the answer, yes, NEC is mandatory now. The earlier regulation also included mandatory, but instead of using the word shall, it has used the word may. So because of may, the word may, people were not really following it. So is there the next question from Mr. Kumaravel? Is there any periodic specific protocol for checking electrical safety of the critical care medical equipment like multi-parameter monitor, defibrillator, etc.? Yes, Mr. Kumaravel, last time we discussed about a standard. I don't remember the number. I think it is IEC 62373 or something like that. The requirement of testing and retesting is also included in the standard. I'm sorry, I don't remember it exactly now. Amaya, do you have any information on that? You can unmute and answer.
Yes. Like not only the critical medical equipments, but every equipment has to be tested. A biomedical engineer in a hospital, they'll do the preventive maintenance periodically. And apart from that, if the medical equipment is repaired or in a serviced after service condition, it has to be tested before it is given back to the desired location for reusing. So lots of procedures are there that it has to be tested before giving, and it has to be tested after giving, and also whether they have to know whether it is working properly or not. So the standard, I'll just check it once again, and I'll just post it on the the Q&A session itself. That answer.
Okay.
The standard.
Yeah. Thank you. So, a question from Mr. Ali Akbar: do you recommend the French standard LPS for hospital or conventional NFPA standard LPS for hospital? Mr. Ali Akbar, please note that the NFPA is not Indian. NFPA is for American people. So NFPA, National Fire Protection Association, they don't recommend any non-standard products. They also recommend as per the Indian standard IEC 62305 or the National Electrical Code. So I don't recommend lightning protection as per the French standard, but sometimes people are fascinated, attracted towards this story by the manufacturer. And if you are attracted towards the story, please read the standard and do it properly. Don't go taken away by the story of the manufacturer. That is the point. I never recommend this non-standard lightning protection. So the next question, Mr. Pandurang, Mahesh Pandurang, in the construction project, what is the minimum electrical safety requirement which we need to implement? Mr. Mahesh, there is a new standard which is under preparation. It is under publication. Probably within a month, it may be coming out. The safety requirements in constructional subjects are also included. Construction projects are included in that. I don't remember those things exactly because I have to refer to the books and answer you. So better, probably we can make one exclusive session for this. There's a question from Mr. Chanchal Banerjee. Should we use a separate fire extinguisher for each room in the critical areas of hospital to combat electrical fire in AC? If yes, what type of fire extinguisher we should use? Actually, I'm sorry, I'm not an expert from fire. Our expert, Mr. Dominic, is not there. Probably he should have answered this question. I'm not the expert. Of course, you should not use the fire extinguisher which is having kind of dust and all. For electrical, you should use, I think, carbon dioxide or something related, the extinguisher with carbon dioxide. So more than that, I'm not an expert to answer. So there is a question from Mr. Dr. S.P. Anchuri. There was a major fire accident in Hyderabad, very nearer to big hospital where chemicals were illegally stored. Fire went in for 8 hours. A lot of deadly smoke was there. Initially, they said it is due to short circuit, but when investigated, the cause was different. Low-rise buildings also most come under NOC. Your comment on height of the building 15 meters to decide the fire protection system. No, my comment on 15 meter is the requirement from the upcoming electrical safety regulation. Every building more than 15 meter must follow NEC. But for hospitals, it has to be carried out irrespective of height. The question again, why AC is more prone in comparison to other electrical equipment? You see here, as I said, until now, the testings were not mandatory. So manufacturers mostly they were trying to minimize the safety requirements, and they were trying to improve the features, like a lot of features which can be advertised. So the importance of safety was quite less, but now once when BIS made it mandatory, now they have to change. Probably the cost also goes up. There is a question from Mr. Parekh. What US standard limit for temperature monitoring while using thermal imaging camera in any electrical panel? I really don't know. This is not my subject. So he's asking, Mr. Dheeraj Parekh is asking what is the thermal limit for the heat from an electrical appliance. Normally it is more than 70 degrees, it can deteriorate the plastic parts for a continuous, not for a short time. So Mr. Dr. Anchari is asking EV chargers in the cellars, any guidelines? Yes, of course, there is a regulation by Central Electricity Authority. Please have a look at the regulation. Also, there are a few standards came up in this direction about electric charging stations. Please have a look. I am not 100% sure about the requirements. So there are several questions, and most of the questions are, like regular questions which we answer, like what kind of earthing, chemical earth, and all those things. So I think it's not a wise decision to answer those questions, because most of the questions are not correct. Somebody is also asking about the insulation monitoring device in medical location make manufacturer. Yes, of course, we are making Cape Electric. We are also making the medical isolation system. We have installed in several places. But as you are aware, during our programs are not for promoting a product, so we don't answer generally this question. But for your information, yes, we are doing. Appavu sir, you can unmute yourself and have your comment, sir.
Thank you. Good morning, Mr. Gopalji. It's a very nice session.
Good morning, sir.
Am I audible?
Yes, you are audible.
It's a very nice session. Again, we have clarified most of the things. I would also like to say a few things about this. First of all, that I think people have raised some standards for BS for medical equipment. I would like to say that it is 13450. It's 13450, which stipulates the and another standard 60601. Both are applicable for medical electrical equipment. And another thing, regarding AC fires, there are some conflicts, as Gopaji stated, there are some conflicts among the standards that has to be addressed. For example, we have protection against overload, short circuit, and earth fault. Of course, earth fault is weaker in TT system, in TN system and TT system, because of confusion of people in making a correct method of connection, making it TT or TN. So, of course, we have complete protection for, let us assume that we are having complete protection for overload and short circuit as well as earth fault. But the thing is, every equipment should also be protected to certain natural, what do you say, hazards in the electrical system. For example, temporary over voltage and impulse withstand. Another thing, high voltage withstand. I think IS 302 specifies correctly the power frequency high voltage withstand test. Actually, this test should be applied between phase and earth. But temporary over voltage is the quality of the equipment which has to withstand certain voltage higher than the nominal voltage. That is, that means the voltage should be applied between phase and the neutral. The 230 volt equipment can't withstand 1000 volt for 1 minute. That 1 minute is for high voltage withstand, and temporary over voltage is for a few seconds, say 2 seconds. But I think even in that case, 1000 volt is very exorbitant. So we have to address the IS accordingly. Of course, temporary over voltage is a phenomenon because of poor earthing system. In lightning earth protection also, there is a mention depending upon the earthing system, the temporary over voltage factor. It depends upon the earthing system as well as the duration of clearance of fault. So we have to incorporate such other things in the IS for
Air conditioner standard. Correct, sir.
Yes.
Right.
Another thing, the TNS earthing system, we are propagating. GOPA is taking much strain across the country to propagate the effectiveness and the usefulness of TNS. Unfortunately, the thing happening in our system is it is not a standalone thing for especially for LT and domestic premises, where the supplier's earthing configuration is not known to the consumer. So that's why adding to the fuel, to the fire, the static meters will not read if you provide a wrong earth connection. So these are the things that people are hesitant in connecting their protected earthing conductor to the neutral terminal, that is PME of the supplier. So there are several things that we have to take into account, and we have to have a separate discussion for that. Another thing, low frequency and high frequency noise voltage mitigation. That's an important area. As Gopaji advised, the medical equipment might have a very good standard of protection and installation, but there is some missing things addressing the EMI interference. People do not mitigate the EMI interference. As he said, segregation and separation, screening of cable. But low frequency require a very good solid earth connection. So these points should also be dealt with separately to for a better understanding on a case-to-case basis in general. That's all my observations, Mr. Gopaji. And I hope that NFE, National Federation of Electrical Engineers for Safety, will bring in more enthusiasm and coordination as well as awareness among the people, like-minded people across this country. I wish all the success for this society to be.
Thank you, sir. Thank you very much. Thank you very much, sir.
Thank you, sir. Thank you.
Thank you. So, Mr. Ravindra Govande, you have raised your hand. You would like to speak, or you can unmute yourself. So, if there is no other questions, of course, there are few questions which. Yes,
Hello?
please.
Yeah, I'm Ravi Govande
can hear
here. Regarding
Yes,
this
please.
insulation monitoring devices only, most of the electrical inspectors in Maharashtra, they are insisting that you provide this device in ICUs and all those areas. Hello?
Okay.
But we found that it is not available, or basically it was issue of make and reliability.
Okay.
Can you elaborate on this?
But this product is available. But it is not only the insulation monitor as a standalone device. You need to also follow the other rules. You need to have a transformer where the leakage currents are very much limited. then the capacity should be limited to certain size. It is not like you can use a very large system. You have the limited size should be used. Then it has to be within certain distance from the operation theater. There are several rules. One of the requirement is insulation monitoring device. The simplest, you see, few decades back, once when these electronic things were not common, insulation monitors were even made with a simple bulb. So there are several techniques, but nowadays a lot of companies have insulation monitor as a standalone device. But as I said, we are making, but what we are making is not the insulation monitor. We are making it as a complete solution. So like let's say like a panel, you can buy and install it. So these are available.
Yeah,
So
but
thank
the
you very much
problem-
for the comment.
Yes, but problem with the electrical inspectors was that they were not aware of the proper type of the system to be provided. They were just insisting on all the hospitals. You have to do it. You have to do it. That's it. That was the actually issue basically. No proper
Okay.
technical specs or what exactly. In fact, one of the electrical contractor asked me whether I can provide it in the main income.
Oh, that is wrong. That is wrong. It
So
has to be
I know
within
it is totally wrong, but this was what was happening in many rural areas, particularly. See, in Bombay or Pune, main cities, lot of technical expertise is available, but particularly in the rural areas, many of the contractors are not even aware of what is exactly to be done. That was the big issue we faced that time.
Okay.
Anyway, thanks a lot.
Yes, sir.
I
We will
details.
find out. We will find out a solution. Thank you. Thank you very much.
Yes, you have.
So we are also conducting classes for electrical inspectorate. 3 months back, we conducted 4 days class for electrical inspectorate in Maharashtra. So we will try to include this as well in the next session. Thank you.
Okay. Thanks a
So
lot.
we have yes, Mr. Sanjeeva Pereira. You have raised your hand and probably.
Yeah.
Yes, please.
Good afternoon. I'm Janaka Kalamut from Sri Lanka. That I just want to say that in the hospital, the HVAC equipment or other load could be installed without the proper feasibility study. Main panel, there could be load, and more than that load, there could be installed in the hospital. HVAC equipment or other load. So it's in the main panel. There's a capacitor bank that could be. Due to the power factor adjustment for the bill saving or the purpose, could be that capacitor bank fire up due to more load or something like that. So there could be a danger in the capacitor bank side, maybe fire up, whole panel fire up, something like that. I just want to say that. Understand what I'm saying?
Actually, Mr. Janaga, your voice is not clear and it was breaking in between.
Yeah.
As a result,
can you hear that now? Okay.
Yes.
Okay.
Yes.
Yeah. That in the hospital, HVAC equipment or other load, maybe some other load could sometimes could install without proper feasibility study. But they were their requirement. Suddenly they could install. So that not carry with the main load. So that time in the main panel in the capacitor bank could be fire up. So I had one experience that I'm saying capacitor bank not carry with the actual load. That capacitor bank could be break up and that could be a very danger in the panel. They fire up or something like that.
Okay. I understood. The point is there is an incident where the fire started from the capacitor panel and the capacitor has broken or exploded and start the fire. Am I correct? Yeah, thank you. Thanks for the comment. Yes, of course, capacitor failures. And you see, once when this MPP capacitor, metallized polypropylene film capacitors were introduced about probably 15 years back, because of its economical cost, people started using it. But later, the market understood that the failure rate is also very high. But now there are good quality solutions available with the manufacturers. They learned from the failure lessons, and a lot of new things are available now. So with this, we will stop the presentation. Actually, I have a flight to catch from Coimbatore at 3 o'clock. I have to now rush to the airport. Thanks. Thank you very much. Thanks to all the participants. Over to you, Ms. Lakshmi.
Yes, sir. I thank Mr. Dominic for giving me the opportunity to give vote of thanks. Thanks to Dr. Vijay Agarwal for the opening remarks. Thank you, Mr. Gopakumar, for sharing your knowledge of electrical safety. Thank you, Ms. Amia Shaji, for being a part of Q&A session. I would like to express my gratitude to all the participants for the presence and contribution to make this webinar a grand success. Hope to meet you all soon at the NFE launch on January 26th at 4 p.m. Thank you all once again.
Thank you very much.
Thank you, sir.
You can stop.